So let's talk about AI. We hear about it constantly, but I think the conversation is missing half the story. What if the so-called old AI, the one nobody really talks about, is actually more important than the new stuff?
Just picture this for a second. A doctor sees a patient, and at the end of the visit, they enter a diagnosis code into a system. Seems like a simple, everyday thing, right?
And then boom, that very same system automatically fires off an alert, flagging a potentially dangerous drug interaction.
Meanwhile, behind the scenes, that one piece of data is being categorized and reported, and it's all perfectly aligned with complex public health regulations.
Every single one of those actions was powered by AI. But it's probably not the AI you're thinking of. This is the other side of AI. It's like an invisible engine that's been reliably running our critical health systems for decades.
So, what is this mystery AI? Well, it's an approach built on a completely different philosophy. It's an AI that follows the rules. It's called symbolic AI, and instead of learning from millions of examples, it's built on explicit human-written rules and structured knowledge. It's a lot like how a human expert would reason through a problem, step by step.
I love how this slide breaks it down. A neural network is kind of like a chef who learns to identify a dish after tasting thousands of versions. They develop this amazing intuition, a gut feeling, but they can't tell you the exact recipe. Symbolic AI is the recipe. A human expert literally writes out the if this, then that instructions, and the AI follows them perfectly, every single time.
And hey, this isn't some newfangled technology. The tools of symbolic AI, things like these rule-based systems and knowledge graphs that map out how things are related, they've been the backbone of health IT for years, providing a solid foundation of logic and structure.
And this all brings us to a really crucial point. You're already using this AI every single day, and you probably don't even realize it. It's the invisible engine powering our public health infrastructure. Think about the International Classification of Diseases, those ICD codes. That whole system, which organizes every known diagnosis, is just a massive symbolic system. Same goes for those drug interaction alerts, the systems that track disease outbreaks, and the tools that make sure hospitals comply with FDA rules. All of these things demand perfect consistency, which is exactly what symbolic AI delivers.
So this kind of begs the question, right? If this system works so well, why is everyone so focused on neural networks? Well, while they are incredibly powerful, they do have some critical weaknesses, especially when you're talking about high-stakes fields.
First off, there's the transparency problem. You can ask a neural network a question, and it'll give you an answer. But if you ask why it gave you that answer, well, it can't really tell you. It's a black box. And in medicine or public health, where lives are on the line, a decision you can't explain is a decision you just can't trust.
Next up is consistency. A neural network might give you slightly different results for almost identical inputs. It approximates. But for regulations and safety alerts, you need a system that applies the exact same logic every single time, without fail. Consistency isn't just a feature, it's a fundamental requirement.
And finally, what happens when there's no data? Neural networks need these massive data sets to learn from. But for a brand new disease outbreak or an incredibly rare condition, that data just doesn't exist. Symbolic AI, on the other hand, can be programmed with expert knowledge right from day one.
So the crucial point here isn't about old versus new. It's about creating a hybrid future that actually gives us the best of both worlds. So how does this actually work in practice? Well, a neuro-symbolic system is pretty elegant. First, a powerful neural network sifts through millions of data points to spot a potential pattern, something that looks suspicious. But, and this is the key, instead of acting on it blindly, it hands that finding over to a symbolic system. That system then applies pre-programmed expert rules and logic to verify it and, most importantly, can generate an alert that explains exactly why it was flagged.
Take a real-world case like drug safety. A neural network can scan millions of patient reports, looking for the faintest signal of a new side effect. The symbolic system then checks that signal against established regulatory criteria to decide if it's serious enough to warrant a formal investigation. You get both the pattern recognition and the verifiable logic.
Ultimately, it really comes down to this simple, powerful idea. The AI of the future won't be one or the other. Neural networks bring the incredible power of pattern recognition, and symbolic systems bring the trust of explainable, reliable rules.
So, I'll leave you with this question to chew on. Beyond public health, where else is this combination of power and trust not just helpful, but absolutely essential? Think about finance, law, or engineering. The future isn't about choosing a side. It's about building a smarter, more trustworthy intelligence by combining the best of both.